Out there, in the unimaginable vastness of space, lie objects of immense power. Black holes, regions where gravity is so strong nothing, not even light, can escape their pull. Imagine a place where the very fabric of space-time is warped beyond comprehension. These aren't just gaps in space, mind you. They're remnants of collapsed stars, crushed to an infinitesimal point, a singularity. The density is unfathomable. Try to picture the Earth squeezed into a marble. That's the kind of density we're talking about. And around this singularity, an event horizon, the point of no return. Cross it and you're lost forever, pulled inexorably towards the singularity. Time itself seems to warp and slow down as you approach this boundary. Now, imagine two of these cosmic behemoths drawn together by an invisible force, their immense gravity an irresistible siren pulling them closer, ever closer. This, my friends, is the prelude to a cosmic dance of unimaginable power. The space-time around them, already distorted, begins to churn and ripple as these titans spiral inwards. Like a pair of figure skaters locked in a gravitational waltz, their orbits tighten, their speeds increasing with each passing moment. This isn't a stately waltz, though. It's a dance of increasing frenzy, a cosmic ballet about to reach its explosive crescendo. The closer they get, the more violent the ripples in space-time become. These ripples, my friends, are gravitational waves. And as these two black holes finally embrace, the universe itself shivers. Let's rewind to the death of a star. Imagine a giant star, much larger than our sun, burning brightly. For millions of years it exists in equilibrium. Nuclear fusion pushes against gravity. But nothing lasts forever. The star's fuel runs out. Gravity seizes its opportunity. The core collapses in a catastrophic implosion. The outer layers blast outwards in a supernova. A core so dense it continues to collapse. Gravity crushes the core into a singularity. A black hole is born. Now, picture two of these stellar remnants, drifting through the vast expanse of space, invisible to the naked eye, yet their presence is felt through the fabric of space-time itself. And that's where the dance begins, governed by a force we all know, yet struggle to comprehend: gravity. Gravity, you see, isn't just about objects falling down. It's about every bit of matter, every bit of energy, pulling on every other bit across unimaginable distances. It's a cosmic dance, and black holes are the most assertive partners on the floor. So when two black holes wander too close, their immense gravity locks them in an inescapable embrace. An invisible tether pulls them together, setting the stage for a cosmic collision of unimaginable proportions. They begin to spiral inwards, their paths intertwined in a deadly dance. Binary dance, a prelude to cosmic chaos. As they draw closer, their orbital dance becomes more and more frantic. Imagine two whirlwinds, spinning closer and closer, their edges blurring in a frenzy of motion. The space-time around them, already warped by their individual gravity, now churns violently. This isn't just a graceful waltz, it's a mosh pit of cosmic proportions. And as the black holes spiral inwards, their orbital speed increases. Imagine two cars racing closer and closer on a collision course, their engines screaming. With each rotation they draw closer, their immense gravity sending ripples through the very fabric of space-time. These ripples, my friends, are gravitational waves. And as the black holes prepare for their final embrace, these waves become more and more powerful, like the tremors before an earthquake. Space-time tango, a dance of distortion. Imagine a silk sheet stretched taut, representing the fabric of space-time. Now place two bowling balls on the sheet. You see how they create dips, right? That's like the gravity wells around black holes warping the very fabric of the universe. Now picture those bowling balls slowly circling each other. The sheet around them ripples and distorts, right? That's what's happening with our black holes. As they orbit each other, they drag space-time along for the ride, creating waves that spread outwards at the speed of light. These waves, my friends, are more than just theoretical ripples. They carry energy. energy drawn from the very movement of the black holes themselves. And as the black holes spiral inwards, these waves grow stronger, more powerful, like the waves of a raging ocean building towards a tsunami. Gravitational symphony, a chorus of waves. These ripples, these gravitational waves, are the universe's way of announcing a cataclysmic event. It's the whisper of the cosmos, a faint tremor that betrays the dance of giants. For centuries, we could only theorize about their existence, predicted by Einstein himself, but impossible to detect. Then, in 2015, we finally heard them. A faint chirp, captured by instruments here on Earth, a signal from over 1 billion light-years away. Two black holes spiraling inwards, their final moments echoing through the universe as gravitational waves. This wasn't just a scientific discovery, my friends. It was like hearing the universe speak for the first time. These waves carry information, secrets about the most extreme environments imaginable. By studying them, we unlock clues about the nature of gravity itself, about the very birth and evolution of the universe. The inevitable. Embrace. A point of no return. Now back to our cosmic waltz. As the black holes draw closer, their orbital speed increases. Imagine two skaters spinning faster and faster, their bodies blurring. The space-time around them is churned into a maelstrom, a chaotic whirlwind of unimaginable energy. We're talking speeds approaching the speed of light now. Unfathomable energies are being unleashed. The gravitational waves are reaching a fever pitch, a cosmic symphony reaching its crescendo. And then, silence. The black holes are so close now that their event horizons touch, a point of no return. From here on out, nothing can stop the inevitable. The two black holes merge, their individual identities lost forever, swallowed by a single, even more massive black hole. The ringdown, echoes of a cosmic cataclysm. Imagine a drop of water hitting a still pond, but instead of ripples on water, it's ripples in space-time. Two event horizons merge into one, two singularities become one. This merger isn't gentle, it's a cosmic collision of unimaginable violence. The newly merged black hole vibrates like a struck bell. These vibrations, powerful gravitational waves, spread outwards. This is the ringdown, announcing the birth of something even more massive. Energy's fury when E-MC2 runs wild. Supernovas are powerful events, but a black hole merger? This makes a supernova look like a damp squib. The energy released is almost beyond calculation. EAMC2 shows mass and energy are two sides of the same coin. In a black hole merger, a tiny fraction of mass converts into pure energy. It's the very fabric of space-time being warped and twisted. Gravitational waves carry this energy outwards, a silent scream across the universe. After the ringdown fades, a new giant emerges. The two original black holes are gone, their mass, their angular momentum combined into a single larger black hole. The event horizon, now larger, settles into its own space-time warp, a cosmic predator with a bigger appetite. This new black hole, still spinning, might be slightly off-kilter at first, like a spinning top about to fall over. But over time, it will settle down, its axis of rotation aligning with the combined angular momentum of the two original black holes. And what happens then? That, my friends, depends on its surroundings. If it's in a dense star cluster, it might go on to merge with other black holes, growing ever larger, a monster in the cosmic night. Or it might remain isolated, a silent giant, its presence only betrayed by the occasional unfortunate star that wanders too close. Imagine a spinning top, fresh from a vigorous twist. It wobbles, oscillates for a bit, trying to find its balance. That's our newly formed black hole, still vibrating from the sheer violence of the merger. It's a bit off-kilter, its event horizon, now larger than the sum of its parents, still rippling. But gravity, the universe's great architect, abhors chaos. It yearns for order, for equilibrium. And so the black hole settles down. Slowly but surely its rotation smoothens out, aligning with the combined angular momentum of the two original black holes. This new behemoth, its event horizon a smooth, featureless sphere, now sits at the center of its own distorted space-time. It's a cosmic predator, its appetite whetted, ready to devour any unsuspecting celestial objects that stray too close. The dance is over, leaving behind a silent giant, a testament to the universe's awesome power. But the story doesn't end there. Remember those ripples in space-time, those gravitational waves generated during the merger? They haven't vanished. Oh no, they're racing outwards, away from the newly formed black hole, carrying the echoes of that cosmic collision across the universe. Imagine dropping a pebble into a still pond. The ripples spread, don't they? Getting fainter, yes, but still traveling outwards. That's what these gravitational waves are doing, spreading outwards at the speed of light, a message from a cataclysmic past. These waves, my friends, are more than just vibrations. They carry information. Encoded within their subtle distortions of space-time are the secrets of the merger, the masses of the original black holes, their spins, the precise moment they embraced in their final fatal dance. For centuries, these gravitational waves remained undetected, a whisper in the cosmic void. Einstein predicted them, but even he doubted we'd ever have the means to detect something so faint, so ephemeral. But human ingenuity, our thirst for knowledge, knows no bounds, and so we built instruments of incredible sensitivity, massive detectors like LIGO and Virgo, capable of sensing changes in distance smaller than the width of a proton. And we waited patiently for the universe to speak. Then, in 2015, it happened. A faint chirp, a fleeting signal, buried in the noise of our own planet, two black holes over 1 billion light-years away, their final moments captured in that whisper of gravitational waves. It was a watershed moment, a new era in astronomy. We weren't just observing the universe with light anymore. We were listening to its heartbeat. Think about it. We've been staring up at the stars for millennia. Telescopes captured the light of distant objects. But now, we're listening as well. Each whisper of gravitational waves is a dispatch. Black hole mergers reveal their secrets. We're gaining insights into gravity. We're active listeners, tuning into the cosmos, uncovering the universe's secrets one wave at a time. We often think of space as empty, silent, but it's anything but. It's a vast, dynamic stage where objects of unimaginable power are locked in an eternal dance. Stars are born, they die, sometimes in spectacular fashion, leaving behind remnants like black holes. These black holes, invisible to our eyes, exert their influence through the very fabric of space and time. They warp, they distort, they collide, sending out ripples, messages that travel for billions of years. And we, here on this tiny planet, have learned to listen. It's a humbling thought, isn't it? The universe is far grander, far more mysterious than we ever imagined. But with our curiosity, our ingenuity, we're beginning to understand its secrets. And who knows what other wonders await us out there in the depths of space, waiting to be discovered. The dance goes on, and we, my friends, have a front row seat.